Hello, today our class is on methods of studying correlation 2. That is, we have discussed three methods in the first class, and now we will discuss the leftover two methods. That is, coefficient of concurrent deviations and Spearman rank correlation. First, we'll see on the introduction concurrent deviation method. Okay, deviations are obtained from the preceding item. While doing so, only the direction of deviation, positive or negative, is taken into account. After ascertaining the sum of the signs, coefficient of correlation is calculated through the formula given. Right. Rank correlation is calculated when two sets of ranks are given. Generally, uh, ranks are given to qualitative characteristics such as honesty, beauty, morality, where these cannot be measured with okay there is no measuring rod to measure all these. They are not quantified. Okay, these are all qualitative aspects which we cannot measure with a okay measuring device. In such a case, rank correlation is applicable. Right. Coefficient of determination is used to explain the causes for variation in the dependent variable, and probable error is used to judge the significance of correlation between the variables. Okay, we will discuss these in this class, right? First, we will see coefficient of concurrent deviations. According to this method, uh, certain correlation between two variables is obtained on the basis of the direction of change of the variables. Uh, the procedure followed to find out the coefficient of correlation by this method is first find out the direction of change of x variables, okay, x variables, and denote them by denote them in a column by dx. Okay, that means to obtain the direction of change, one value of series is compared with its preceding value. If the value is greater than its preceding value, the direction of change is denoted by plus sign. Okay, on the other hand, if a value of is lesser than its preceding one, the direction of change is denoted by minus sign. Okay, following. If you if a value is equal to that of its preceding value, the direction of change is said to be constant and denoted by 0. This process is repeated for all the values of x series, and the outcome is denoted by dx. Right. We'll see. Second step is find out the direction of change of y variable. Okay, and denote the column by dy. Find out the direction of change of y variable and denote the column by dy. The same procedure which we have adopted for dx is also followed for dy. That means to obtain the direction of change, one value of a series is compared with its preceding value. Okay, for the first one we don't have any preceding value. For the second one we will have the preceding value as the first one. That is, in the same manner we need to follow this one. And in the third step, find out the product of dx and dy and obtain the value of c. Find out the product of dx and dy and obtain the value of c. That is the number of concurrent deviations. Okay, the number of concurrent deviation. That means dx, you will get dx while uh, uh, okay, looking at the values of given series, preceding value, comparing the values from the preceding value, you will put plus or minus signs and you will count them. Then these plus or minus signs of dx will be multiplied with the plus or minus signs which we are getting on the calculation with the corresponding values, and we will get dx into dy. uh, okay, right. In the uh, fourth step, find out the value of n by deducting 1 from the total number of pairs of observations. Okay, that is small n is equal to capital N minus 1. Why we are deducting 1 is we are not having, okay, we are not considering, we are not getting any value for the first one because of lack of preceding value. Right. Next, In the fifth step, compute the coefficient of concurrent deviations by using the following formula that is given in the PPT. If you look at the PPT, you will find that RC, okay, which is equal to plus or minus, right, under root plus or minus 2c minus n by n, okay, plus or minus 2c minus n by n, okay, where RC is equal to coefficient of concurrent deviations and C is the number of concurrent deviations. C is the number of concurrent deviations, and small n is equal to number of pairs of observations less 1, because we don't have, we are not considering all the, okay, values which are given in the series, only we are taking pairs of observations, okay. One is missing than the number of, because the first one will not have any preceding value, right? If 2c minus n is okay, positive, the positive sign must be used with the root, okay. We are taking plus or minus, hence in order which we use plus either minus, in order to know that, okay, if 2c minus n is positive, right, the positive sign must be used within the, okay, root, so that RC is positive. On the other hand, 2c minus n is negative, the negativeness sign under the root must be used so that RC is negative, right? The following one, if we take one example for this, okay, for the better understanding of this, we will go through an example. It is calculate the coefficient of correlation by using concurrent deviation method. Okay, he has given years 1976, 1977, 1978, 1979, 1980, 1981, 1982, 1983, 1984, and he has also given the corresponding supplies in the years, that is 250, 270, 260, 275, 280, 290, and 290, 285, 292, and also given the price, that is in the year 1976 that is 150, in the year 1977 130, 78, 140, 79, 135, and 80, 132, 81, 130, 82, 130, and 83, 131, and 84, 127, 127. With this we need to uh, find out the direction of change. Okay, in the first, for in the 1976 the supply is 250. Okay, we don't know the preceding year value, hence we'll leave it. Okay, we don't put any sign, because we are not in a position to compare the same, right? In the year 1977 you have the 270 units of supply. When you compare the same with the preceding year, there is an increase, hence we need to put the positive sign. In the year 1978 260, when you compare with the preceding year, that is 270 to 260, means decreased, you need to put minus sign. In the years 278, that is 260, and in the year 279, and that is 275, there is an increase, hence we need to put plus. From the 279, okay, from 1979, 1980, 275 to 280, there is an increase, we need to put plus sign. In the year 1981, okay, 290, in the year 1980, 280, there is a increase, hence we need to put again plus sign. In the year 81, 82, the supply is same, hence there is no increase or decrease, we need to put 0. In the year 1983, when compared with the preceding year, that is 1982, supply in 290, in the year 285, there is a decrease of 5 units, hence we need to put a negative sign. In the year 1983, 285, and whereas in case of year 1984, it was there is an increase of 7 units. That's why we need to put positive. In the same way, we need to find out the direction of change of y, that is given as price. Okay, in the first year we don't have any preceding year value, hence we leave the same. and in the second year the preceding year value is 150, whereas in the year second year, that is in the year 1976 it is 150, in the 1977 it is 130. That means there is a decrease, hence we need to put minus sign. In the year 77 130, 78 it was 140. That means there is an increase, hence we need to put positive sign. Whereas in case of 1979, that is 135, whereas in the preceding year 1978 is 140, hence there is a decrease, we need to put negative sign. In the same manner, 79 135, 80 132, there is a decrease, hence we need to put minus sign. In the year 1981 130, preceding year is 132, minus sign. In the year 1982 130, preceding year is also 130. That means there is no change. Okay, of course, but that we need to put 0. Wrongly here we denoted as plus, but we need to put the 0. Okay, there is no increase or decrease, right? In the year 1983, it was when compared with the preceding year, it was a small increase, that is 1, hence we need to put plus. In the year 1984, we need to okay, if you see 83, when we compare the same with the 83, 131 to 127, there is a decrease, hence we need to put a negative sign. If you multiply these dx and dy, the direction of change of values, that is signs. First, in the year 1977, that is plus sign, in the supply is plus and price is minus. Hence plus into minus minus. The same manner we need to multiply all. 78 minus into plus minus. In the 79 plus into minus minus. In the 80 plus into minus minus. 81 plus into minus minus. 90 0 into 0. Okay, 0. And in the 83 minus into plus minus. 84 plus into minus minus. Okay. From the data we got, okay, dx into dy is nothing but c, which is equal to 0, because we find all are negatives, right? Hence the change of direction, okay, we need to count the positions. C is equal to 0. Hence n is equal to number of pairs of observations are the total number of items, that are 9, and minus 1, that is 8. Substituting these values in the given formula, RC is equal to plus or minus, okay, under root plus or minus 2 into, we got C value is 0, minus 8 by 8. Okay, hence as we got all the minuses, we put minus under root 8 by 8. Okay, 2 minus 0, okay, 2 minus 0, minus 8, plus or minus 8, minus will be taken out. Okay, minus into plus minus only, 8 by 8, hence which is equal to minus under root 1 minus 1. Okay, 1 under nothing but 1 minus 1. The coefficient of concurrent deviations is minus 1. With this we will calculate, right? And if you go through the another example, okay, we'll see another example for better understanding. Here he is asked to calculate the coefficient of correlation by using concurrent deviation method. Okay, the data is given as marks in accounts 60, 70, 80, and 80 and 75, 72, 71, 78, 82, 85, 83, and direction of change, that is dx, and we need to find out marks in stats also given, that 65, 63, 64, 60, 60, 68, 67, 80, 79, and 78. First we will consider direction of change for accounts. That is for the first we don't know the preceding value, we leave it, and for the second 60 to 70 it is increase, plus 70 to 80 it is also increase, plus 80 to 75 it is a decrease, minus 75 to 72 it is also decrease, minus, and 72 to 77 there is an increase, plus 77 to 78 there is an increase, 78 to 82 increase plus, say 82 to 85 plus, and 85 to 83 there is a minus. Then marks in stats, okay, dy, if we consider it as y, we need to calculate the y for this. For the first year we don't have preceding year value, we don't know, hence we will consider second. uh, from first year we got second year, okay, marks for first one we got second, there is any decrease, that is 65 to 63, hence we will put minus. 63 to 64 there is an increase plus, 64 to 62 there is an decrease minus, 62 to 66 there is an increase plus, 66 to 68 there is an increase, hence we put plus, 68 to 70 67 there is a decrease, hence we put minus, 67 to 80 there is an increase, hence we need to put plus, 80 to 79 we need to put minus, 79 to 78 there is a decrease, we need to put minus. Now we multiply the direction of change of x series with direction of change of y series, that is signs, plus into minus minus, plus into plus plus, minus into minus plus, minus into plus plus, minus, plus into plus plus, plus into minus minus, plus into plus plus, minus into minus minus. We got c is equal to 5, that is positive, okay, hence rc is equal to plus or minus under root plus or minus 2c minus n by n. Here c is equal to 5 and n is equal to 9, that you know, okay, then because there are 10 pairs of observations are considered and 10 minus 1 9, substituting these values, rc is equal to plus or minus under root plus or minus 2 into 5 minus 9 by 9, that is plus or minus under root plus or minus 10 minus 2 into 5 is nothing but 10, 10 minus 9 by 9, that is under root 1 by 9. If we got plus, hence we need to put plus, plus 0 under root 0.111, which is equal to plus 0.333 is the value. The coefficient of correlation by the method of concurrent deviation, okay, is 0.233, right. Now we will see the merits and limitations of concurrent deviations, okay. First we will see the merits of concurrent deviations. This is the simplest method of computing coefficient of correlation between two variables, okay, and this method is used to obtain a rough idea of the relationship between the variables before the complicated methods are used, okay. When the data contain larger number of items, it is very easy for to calculate. Like, next, it is useful to study the short-term fluctuations in the data. Okay, it is useful to study the short-term fluctuations in the data. And now we will see the limitations. Okay, and this method emphasizes only the direction of change, but it does not measure the degree of relations, okay, in precise terms. In precise terms we cannot measure the degree of relationship. This is one limitation that we have regarding the concurrent deviations, and this is not concerned with the extent of change in the values, okay. It gives equal weightage, okay, equal weightage to both big and small changes if they vary in the same direction, that we have seen, okay. Of course, if you got 100 to 50, there is a minus, 100 to 99 also you will put minus. Of course the variations are very big, but we are not considering the size of the variation. This is another drawback. And third is it is not useful to study the long-term changes in the data, as it does not take the trend into account, okay. It is not useful to study the long-term changes in the data, it does not take the, okay, trend into account, as we are ignoring the trend, that is, okay. in the long term, hence it is not, that is also one limitation. The fourth one is the results obtained by this method give only a rough idea of relationship between the variables. Okay, between the variables only we will get a rough idea of the relationship, but we don't know the actual what we call as impact that has in the given problem. Now, rank correlation coefficient. We'll discuss rank correlation coefficient. Okay, Charles Edward Spearman developed another method of finding out correlation between two variables. Okay, this method is used when the data are not normal or when the shape of the distribution is not known. This method is especially useful when the characteristics of items are not subject to direct measurement. For example, certain variables like judgment of female beauty, evaluation of leadership ability, etc., cannot be measured directly in quantitative terms because there is no measuring rod to measure the qualitative items, right? In such cases, the relationship between the variables is obtained by ranking the items. Ranks are assigned to all the items in the series in order of their size. Okay, in order of their size. That is, the highest value in the series is given first rank. The next highest value is given the second rank, and so on. An alternative way of assigning the ranks is that the lowest value in the series is given, okay, can also be given the first rank. The next lowest value can be given the second rank, and so on. According to this method, all the calculations are based on ranks rather than the original values of the observation. Okay, and Spearman's rank correlation coefficient is denoted by rho. Okay, that is RHO, we can pronounce it as rho, and computed as uh, with the help of a procedure, that is assign ranks to the items of first series and denote them by R1. Assign ranks to the item of the second series and denote them in a column by R2. Obtain the differences of the two ranks, that is R1 minus R2, and denote these differences by D. Apply the formula that is given in the PPT. Rho is equal to 1 minus 6 sigma d square by n cube minus n. Okay, where the d is equal to difference between R1 and R2, and is equal to number of pairs of observations. Okay, the value of this coefficient ranges between plus or minus, while plus 1 indicates complete agreement in the order of the ranks, and minus implies the complete disagreement in the order of the ranks. The complete agreement in the order of the ranks indicate that the ranks are in the same direction. On the other hand, the complete disagreement in the order of ranks indicate that the ranks are in the opposite direction. Okay, and we will consider one problem for better understanding of this Spearman's coefficient of rank calculation. Here, the marks in accounts is given, that is 60, 48, 52, and 50, 55, 62, 65, 70, 65. Marks in statistics also given, stats, that is 72, 62, 68, 65, 70, and 60, 64, 55, 52, 79. We need to find out the terms which are required to calculate the Spearman coefficient of rank correlation, that is R1, R2, and D also we require D square, right? In order to find out the R1, okay, first we need to give the rank to the highest value. In the given series, if you observe the marks in accounts, the number which is the biggest number in the given series, the highest, okay, number is 70, 70 I am giving the first rank to the 70, and 68 is the second rank. In the same way, 65 third rank, 62 fourth rank, okay, and 60 fifth rank, uh, 55 sixth rank, 52 seventh rank, 58th rank, and 48 ninth rank. Okay, all the ranks were given. For the marks in statistics, okay, we need to consider the way, okay, highest value, that is highest value in this is 79, hence I am giving first rank to that. 72 is the second value, highest second value, hence I am giving the second rank to that. In the same manner, 70 will get third rank, 68 will get fourth rank, and 65 will get fourth rank, 62 will get sixth rank, 60 will get seventh rank, and 55 will get 8th rank, and 52 will get 9th rank. Now we got R1 and R2. We need to, in order to get the D value, we will subtract R1 minus R2. That is 5 minus 2 is 3, 9 minus 6 is 3, 7 minus 4 is 3, 8 minus 5 is 3, 6 minus 3 is 3, 4 minus 7 is minus 3, 3 minus 8 is minus 5, 1 minus 9 is minus 8, and 2 minus 1 is 1. Now we need to square the deviations, that is R1 minus R2 is equal to D whole square, that is R1 minus R2 whole square, nothing like, right? 3 whole square is nothing but 9, 3 square is nothing but 9, 3, 9, 9, 9, 9, you will get all the 9s almost till okay, last 3, and minus 5 whole square is 25, minus 8 whole square is 64, 1 whole square is 1. Now we need to summate all these, okay, that is sigma d square. Okay, we need to total all these, okay, add all these values and you will get sigma d square, that is equal to 144. According to the formula, that is rho is equal to 1 minus 6 sigma d square by n cube minus 1. Here 1 minus 6 into sigma d square value we got 144. Okay, hence we need to substitute the same 1 minus 6 into 144 by n value is 9, hence 9 cube minus 9, which gives rise 1 minus 6 into 144 is nothing but 864 by 729 into 9, 720, sorry, 9 into 9, 81 minus okay, 81, sorry, 81, not 81, 729, 729 minus 9 is nothing but 720. Okay, hence 1 minus 864 by 720. 1 minus 864 by 720 is nothing but 1 minus 1.2, which 1 minus 1.2 is nothing but 0.2. Thus the rank correlation coefficient is 0.2. Okay, that we got from the given solution. Next, we'll see when equal ranks are given. Okay, how could we calculate the experiments from correlation? Sometimes there may be 2 or more individual items which may have equal values. In such cases, okay, each individual item is given an average rank. For example, if 2 individual items are ranked equal at third place, each of term is given the third 3.5th rank. That means 3 plus 4 by 2, that is 3.5. Okay, will the positions will be added and divided by the number of places we are considering. If 3 items are ranked equal at third place, each of the item is given the fourth rank. For example, third place, after third place value is same, fourth place value is same, fifth place value is same. Hence we need to add all these 3 plus 4 plus 5 by 3, that is fourth rank is given. In other words, when two or more items are to be ranked equal, they are given the average of the ranks with which these individual items would have got. Had they differ from each other. In such cases, rank correlation coefficient is calculated after adding 1 by 12 into m cube minus m to the value of the sigma d square in the original formula. Here m stands for the number of items whose ranks are uh, okay whose ranks are common. If more than one such groups are there with common rank, the adjustment factor will have to be added to the value of sigma d square. As many number of items as the number of such groups, thus the formula can be written as 1 minus 6 into sigma d square plus 1 by 12 into m cube minus m plus 1 by 12 into m cube minus m by n cube minus n. Okay, now we will consider one problem for better understanding. That is, computation of rank correlation coefficient is uh, okay so xi and y series are given. X series values are 60, 55, 60, 70, 45, 35, 27, 60, and y series values are 40, 35, 40, 35, and 38, 42, 35, 50, 48, 60. Now we will consider calculate r1 and r2 from x series. For x series we will calculate r1. Say in the highest is 70, hence I am giving first rank to 70. Second rank, if you see second rank, for second rank if you see, and the value of 60 will get second rank, and 60 will get third rank, and 60, there are three 60s, will get fourth rank. Hence 2 plus 3 plus 4, that is 5 plus 2 plus 3 plus 4 is nothing but 5 plus 9, which 9 by 3 is nothing but 3. Hence all the values which have the same value will get same rank, that is 3. Hence 60 got 3, 60. After 3 you have given uh, 2, 3, 4 ranks are given, and leftover is fifth rank is leftover. Hence after if you consider the highest value after these, 55 will be the highest. Hence I'll give the fifth rank to 55, and sixth rank to 45, seventh rank to 35, 27 will get eighth rank. This will be, there are number of pairs of observations are 8 only, and for y we need to calculate r2. Here the highest value, that is is 60. Hence I am giving first rank to 60. The next highest number is 50. Hence I am giving second to 50, and hence the next highest is 48. Third rank is giving, I am giving to 48, and next highest is 42. Hence I am giving fourth rank to 42. Next highest is 40. I am giving fifth rank to 40, and next highest is 38. That is, I am giving sixth rank to 38, and lastly, and the uh, 35 is occurring twice, and we have only uh, for giving the rank 35 plus 35, that is 7th and 8th rank will be given. 7 plus 8 by 2 is nothing but 7.5. Hence I am giving, they are same values we got, hence I am giving the same rank. Now we need to subtract from r1 minus r2, that in order to get the due. That is r1 3 minus 5, and that is minus 2.0. 5 minus 7.5 minus 2.5. 3 minus 6 minus 3.0. 1 minus 4 minus 3.0. 6 minus 7.5 minus 1.5. 7 minus 2 5.0. 8 minus 3 5.0. 3 minus 1 2.0. Then r1 minus r2 whole square equal d square, that is 2 whole square is 4, 2.5 whole square is 6.25, 3.0 whole square minus 3.0 whole square is 9, minus 3.09 minus 1.5, that is plus 2.25, 5 whole square is equal to 25, 5 whole square is equal to 25, 2 whole square is equal to 4. We got these values. Now we need to add the d squares. Okay, add all the values of the d squares, that is sigma d square we need to get, that is 84.50 we got by adding all the values of d square. Sigma d square 84.5 we got. N is equal number of pairs of observations are 8. The item 6, as we saw that in the x-rays, item 60 is uh, occurring 3 times. Okay, that is m is equal to 3. The item 35 is repeated twice in series y, so m is equal to if we consider the formula, that is 1 minus 6 sigma d square, okay, 6 into sigma, the bracket of sigma d square plus 1 by 12 bracket m to m cube minus m plus 1 by 12 bracket of m cube minus m bracket close, and by n 3 minus n. Substituting the values in this formula, 1 minus 6, okay, d square value we got is 84.5, okay, plus 1 by 12, okay, 1 by 12 into 3 cube minus 3, this is for the first series, m value of the first series, plus 1 by 12 into m cube minus m, and this is the value of the second series, that is okay, 2 cube, m value is 2, 35 is occurring 2 times, hence m value is 2 here, okay, 2 cube minus 2, then by number of observations, n value is 8 cube minus 8, that is 1 minus 6 into 84.5 plus 1 by 2 to 3 cube minus 3 is nothing but 27 minus 3, that is 24, plus 1 by 12, okay, to 8, 2 cube means 8, 8 minus 2 is 6, okay, hence 6 by 504. 504, how could you get that? 8 whole cube minus 8, that is 512, minus 8 is nothing but 504. 1 minus 6 into 84.5 plus 24 by 12 is nothing but 2, plus 6 by 12 is nothing but 0.5 by 504. If you simplify further, 1 minus 6 into 84 plus 84.5 plus 2, 86.5 plus 0.5, 87. Okay, 6 into 87 by 504. 1 minus 6 into 87 is nothing but 522 by 504. Okay, 1 minus 522 by 504 is nothing but 1.0636. Okay, 1 minus 1.036. 522 by 504 is 1.036. 1 minus 1.036 is nothing but minus 0.036. Thus, rank correlation coefficient is equal to minus 0.036. Okay, merits and limitations of rank correlation coefficient we'll see now. Merits, it is the simplest method of calculating correlation between two variables. Okay, and second is when we are not given original data and only the ranks are given, this is the only method of computing correlation coefficient, right? In the third merit is that in case of qualitative data which cannot be measured directly, okay, this method is used to calculate correlation coefficient by simply assigning the ranks to the attributes, okay, such as honesty, beauty. We are not in a position to measure them directly because there is no measuring rod to measure all these, hence we may rank these attributes and we will measure. Fourth merit is this method is not affected by extreme values of series, as correlation coefficient is calculated not on the basis of original values but on the basis of ranks assigned to them. Okay, we are not considering the original values, whatever the may be the uh, variation in the values. Okay, we are giving the highest value, we are not taking only the highest and lowest, highest, we are comparing the values, we are giving ranks to them, hence it's one good method. Limitations we will see. Limitations of rank correlation coefficient are This method gives only a rough idea of the relationship between the variables, as the calculations are not based on the actual observations, right? This method is not useful for computing correlation between the variables when the observations are fairly large. Okay. uh, Not useful. This method is not useful correlation between the variables when the observations are fairly large. Okay, especially when the observations are more than 30, ranking becomes difficult and cumbersome. Okay, cumbersome. And that means more than 30 observations will become difficult. Sometimes if the same ranks occur, we may get confused which rank. Okay, we need to, right? It will be complicated. It will become complicated, but we can calculate, right? And this method is useful to compute correlation in the case of single observations only. Okay, and this method is useful to compute the correlation in the case of single observations only. It is not useful in the case of grouped frequency distributions. Okay, that is one another drawback that we have. Now we will see coefficient of determination. What is coefficient? Coefficient of correlation reveals the direction of degree of relationship between the variables. Okay, it does not specify the reason of change in the variables. The change in the dependent variable may be due to two factors. One is a variation in the independent variable, and the second is variation unaccounted by the independent variable and due to some other factor. Okay, the extent of variance in the dependent variable due to the independent variable is explained by the coefficient of determination. Okay, uh, coefficient of determination is equal to r square and is the ratio of the explained variance of the total variance. The we can consider the formula, that is coefficient of determination. Okay, coefficient of determination is equal to, okay, explained variance by total variance, right? uh, Coefficient of determination is a convenient and useful statistical technique of interpreting the values, okay, of correlation coefficient. If the coefficient of correlation between two variables is 0.6, coefficient of determination would be 0.36. Okay, this would mean that 36% of the variation in the dependent variable is due to the independent variable, and the remaining 64% of the variation is due to the other factors, right? I will come to know the effect or impact of independent variable and other factors on the dependent variable, right? The relationship between r and r square. Okay, we'll see in the table. If you look at the ppt, you will find that. That is 1 is the value. R square will be 1 and percentage of explained variance will be 1. 0.9 is equal to 0.81 will be the R square and 81%. 0.8 is equal to 0.64, that is 64%. 0.7 is equal to 0.49, that is 49%. 0.707, that is 0.50, 50%. 0.6 is equal to 0.36, that is 36%. 0.5 is equal to 0.25 R square value, then 25%. 0.4 is equal to 0.16 is the R square value and 16%. 0.3 is equal to 0.009, that is 9%. 0.2 is 0.004 will be the R square, that is 4%. 0.1 is nothing, whole square is equal to 0.01, which is equal to 1%, right? It is clear from the table that the value of R decreases from its maximum value of 1. The value of R square also decreases, but at a more rapid rate. Usually the value of R is always greater than the value of R square. Okay, unless R is equal to 0 or 1, in which case R is equal to R square, right? Further, the value of coefficient of determination is always positive. Okay, the value of R square may quite often mislead the readings. Example, correlation between two variables is equal to 0.8 and the correlation between two other variables is 0.4. It does not mean that the correlation between the first two variables is double the correlation of, okay, between the second set of variables. The relationship between the variables can be better understood by computing the values of their respective coefficient of determination. The coefficients of determination would be 0.64 and 0.16 respectively. This indicates that in the first case, 64% of the total variation in the dependent variable, and in the second case, only 16% of the total variation is explained by the independent variable. The usefulness of coefficient of determination is clear from the observations of Turtle, who states the results of correlation analysis has been grossly overrated and is used entirely too much. It's a square. The coefficient of determination is a much more useful measure of the linear uh, covariation of two variables. The reader should develop the habit of squaring every correlation uh, coefficient he finds cited or stated before coming to any conclusion about the extent of the linear relationship between the two correlation variables. Okay. Uh, though these are considered as uses, and though the coefficient of determination is a useful measure of interpreting the values of correlation coefficient, it does not establish any sort of causal relationship between the variables. This has to be determined on the basis of evidence other than the quantitative observations. Another limitation of coefficient of determination is that it always a positive number, thus it does not tell us the direction of covariation of the variables, right? However, correlation coefficient and coefficient of determination is used together will serve a better analytical purpose. Okay. uh, the combined usage of correlation coefficient and the coefficient of determination is very common in economic analysis, right? And probable error, the reliability or significance of correlation is determined with the help of probable error. The probable error helps in interpreting the values of coefficient of correlation. Okay. uh, According to Horace Sechrist, the probable error of R is an amount which, if added to and subtracted from the average correlation coefficient, okay, produces amounts within which the chances are even, okay, that a coefficient of correlation from a series is selected at random will fall. According to Walden, probable error defines the limits above and below the size of the coefficient determined within which there is an equal chance that coefficient of correlation, similarly calculated from other samples, will fall. The probable error of the coefficient of correlation is calculated with the help of formula that is given here, that is a P probable error PER is equal to 0.6745 into 1 minus r square by under root n, where 0.6745 is a constant number and r is Pearsonian coefficient of correlation and n is the number of pairs of observation. Okay, probable error of coefficient of correlation, okay, will be interpreted in this as if the values of coefficient of correlation is less than the probable error, it can be said that there is no evidence of correlation between the variables under study, right? If the value of coefficient of correlation is greater than 6 times the probable error, the coefficient of correlation is said to be practically certain. Okay, and another one is the upper and lower limits which the value of coefficient of correlation in the population lies are obtained by adding and subtracting the values of probable error from the concerned coefficient of correlation. Okay, symbolically, um, rho is equal to r plus or minus PR, where rho denotes correlation in the population, right? Conditions for the use of probable error, according to Riggleman and Frisbee, the statistical measures of probable error can be properly used only when the three conditions are exist. That is, first condition is that data must approximate normal frequency curve, that is a bell shaped curve. Normal frequency curve, we have seen that it is a bell shaped curve, And the third, the statistical measure for which the probable error is computed must have been calculated from a sample. Third one is the sample must have been selected in an unbiased manner, and the individual items must be independent. Okay, we will take one example for better understanding here. What it has given is if r is equal to 0.4 and n is equal to 16, find out the probable error of the coefficient of correlation and determine the limits for the population of coefficient of correlation, that is rho. We will take the formula probable error is equal to 0.6745, which is constant, into 1 minus r square by under root n. We know that r is equal to 0.4 and n is equal to 16. Now we substitute the same in the formula, that is 0.6745 into 1 minus r square is 0.4 whole square by under root 16, that is 0.6745. 1 minus 0.4 square is equal to nothing but 0.16 by under root 16, that is 0.6745 into 1 minus 0.16 is nothing but 0.84 by under root 16 is nothing but 4. Then 0.6745 into 0.84 is 0.567 by 4. This is equal to 0.142. Limits of population is 4 plus r minus 0.142. Okay, which is equal to 258. Okay, minus, that is 0.542. That means limits of population ranges between 258 minus 0.542. Okay, with this we have concluded the lesson. Thank you.